Hello Chem class. Today we're going to be working with half-life problems, and in specific in this video we're going to be covering fractions of material left, and we're going to focus on carbon-14 problems with this as well, although this should be relatively similar for any isotope. So let's get started. What fraction of carbon-14 will remain after 3 half-lives? For this we're going to have to set up our table. Here we have the start of our table, and these two columns are always going to be the same no matter what problem you're doing, so that makes things at least a little bit easy to start with. So we're going to plug in our number of half-lives, and it's very important when you do these problems that you start at time 0, and so your number of half-lives is actually going to be 0, which means you have the whole sample left, so we could write 1 over 1 if we wanted to there. After we go through 1 half-life, by definition that means that we should have a fraction of 1/2 of our material left. When we go through a second half-life, we should be at 1/4 or half of half. And when we get to the third half-life, we are down to 1/8. So when you're doing the fraction left column, you are always dividing by 2 in order to get your fraction left. At this point we can answer the question, because it says what will remain after 3 half-lives. Well, we can see that our at 3 half-lives here we have 1/8 left. So the answer to this first question here would be simply 1/8. If we change our question to say what fraction of carbon-14 will remain after 22,800 years, it's still handy to have these first two columns for your chart, but now we're going to have to add another part to this. Our new column here is age, and that's always going to have a time unit. This is a column that will vary depending on what the material is that you're dealing with. The unit could be seconds, it could be hours, minutes, years. In this case, we're going to be dealing with years, and carbon-14 value we said is 5,700 years for a half-life. Note that what I'm going to do here, though, is at 0 time, I'm actually going to be putting in a 0 for the age. Don't make the mistake of putting the 5,700 first. The 5,700 years doesn't happen for carbon-14 until the first half-life. At this point, for age, we are going to be adding 5,700 each time. This is different than the divided by part that we did on divided by 2, so please don't multiply by 2 or divide by 2 in this column. It's adding 5,700 every time. So when we go through a second half-life here, we are going to be going up to an age of 11,400 years. And then when we get to 3 half-lives, we're going to add 5,700 yet again, and that gets us to 17,000. There we go. And we are trying to get to 22,800 years, and we're not quite there yet. So we're going to have to add a 4th row to this thing. So we're going to say number of half-lives 4. We're going to divide by 2 again. That's going to give us 1/16. And now when we add 5,700 to our 17,100, we get 22,800 years. So what this is telling us here is that the answer to our question is going to be 1/16. That's the fraction left after 22,800 years. Okay, so those are some questions dealing with the fraction. I'll try to do some more videos with some other carbon-14 problems and post them as a separate video. Over and out. 100, whoops.